what about the anionic nucleophile and what are the anionic nucleophile and neutral nucleophile, and how it is changing in the group as well as in the period. Then what is alpha effect? Then what are the change in nucleophilicity by changing the solvent. Okay, that is effect of the solvent. Then what is leaving group and how to arrange the leaving group aptitude. So these are the things we have discussed in the last class along with some conversion. Friend, if you have any doubt, quickly write in the chat box. यदि ये टॉपिक रे किसी डाउट अछि any doubt? I think now the screen is visible. Okay, summary koi do. Okay, sure. Now you can see the screen. Yes, factors affecting nucleophilicity. First of all, what is nucleophilicity? Nucleophilicity means it is the rate of attack of nucleophile to the electrophilic carbon. The rate of attack of nucleophile to the electrophilic carbon, that is known as nucleophilicity. So, other words हम कही परिबा electrophilic carbon को काहे attack करिवो? Because nucleophile has electron density. Kahe na nucleophiles means nucleus loving. Nucleus loving means those are having which charge? Those are having negative charge or negative charge center. Those are having negative charge or negative charge center, right? Acha. So negative charge center koti achi with the nucleophile. Tamane more the availability of negative charge electron with the nucleophile, more is the nucleophilicity. Which parlo? The nucleophilicity kaha pe depend karibo? Na nucleophilicity depend karibo on the nucleophilicity depends on the availability of the negative charge. Depends on the availability of the negative charge. More the availability of negative charge, more is the nucleophilicity. So first, then हम देखिबा between neutral nucleophile and the anionic corresponding anionic nucleophile. For example, जब देखिबा OH minus and H2O. So obviously negative charge अछि माने electron density, charge density is more with the anion as compared to the neutral nucleophile. So anionic nucleophiles are better than the corresponding neutral nucleophiles. OH minus has more nucleophility than H2O. CH3O minus has more nucleophile than CH3OH and so on. Then second, in group, moving down the group, what is happening? Moving down the group, nucleophilicity decreases. As moving down the group, the vacant orbitals increases and backbonding increases. Then charge density decrease. Next, in period, moving across the period, atomic size will be almost comparable. Then our size criteria ashibo. Eti kon ashibo? Na electronegativity criteria ashibo. More the electronegativity, lesser is the tendency to donate the electron, and hence lesser is the nucleophilicity. Or in other words, lesser the across the period, the nucleophilicity decreases due to increase in the electronegativity. So alpha effect माने कोन? The alpha position रे nucleophilic center रो alpha position रे किछि electron releasing group अछि, then what will happen? It can increase the electron density of the nucleophile. The nucleophile electron density increase hobo, tale nucleophilicity कोन होबो? Increase होबो. So that is alpha effect. Similarly, जदि electron withdrawing group रहिबो alpha position रे, तले the nucleophility कोन होबो? The nucleophilicity decrease हेजिबो. Okay. So electron releasing group at the alpha position increases nucleophilicity, and electron withdrawing group at the alpha position decreases the nucleophilicity. Okay. So effect of solvent. So solvents are of two types, polar and non-polar. Polar solvent is of two types, polar protic and polar aprotic. So protic means जे कि proton donate कर परियो और H plus donate कर परियो. So polar protic रे हम कहि पारे water, alcohol, carboxylic acid. Polar aprotic रे ketone आसीबो और THF tetrahydrofuran, DMSO, di methyl sulfoxide. Okay. सो ये सब आसिले तुमर अंडर द पोलर एप्रिटी जदि मैं स्टूडेंट म्यूट योरसेल्फ स्टूडेंट म्यूट योरसेल्फ सो हम जे देखिबा पोलर प्रोटिक सॉल्वेंट रे कोन हबो ना सम न्यूक्लियोफाइल्स विल बी हाईली सॉल्वेटेड यदि सॉल्वेटेड हबो देन तार न्यूक्लियोफिलिसिटी डिक्रीज हो फॉर एग्जांपल हम जे देखितिले स्टार्टिंग फ्रॉम फ्लोराइड टू आयोडाइड न्यूक्लियोफिलिसिटी डिक्रीजेस एज आयोडाइड हैज वैकेंट ऑर्बिटल बट से जे हम देखिबा पोलर प्रोटिक सॉल्वेंट रे ऑर्डर विल बी रिवर्स कहीं कि ना आयोडाइड विल बी लेस सॉल्वेटेड व्हेreas फ्लोराइड विल बी हाईली सॉल्वेटेड यदि फ्लोराइड हाईली सॉल्वेटेड हबो तार कोन हबो ता न्यूक्लियोफिलिसिटी डिक्रीज हो रेट ऑफ अटैक डिक्रीज हो ओके सो दिस इज द इफेक्ट ऑफ द सॉल्वेंट then आम डिस्कस करथिले living group means this is an atom or group of atoms which can be released from the carbon center in the form of anion okay or by taking the shared pair of electron and after getting released from the carbon center as anion it has to be stabilized in the medium ଯେମିତି ଗୋଟେ anion release ହେଲା ପରେ ସେ stability ନ ହବ ସେ ନିଜକୁ ନିଜେ stable ନ କରି ପାରିବ medium ରେ then it will be reversible ସେ ଆଉଥରେ ପୁଣି return ହେଇଯିବ carbon center ପାଖକୁ so କଣ ହେଲା ନା first it has to be released in the form of anion and it has to be stabilized in the medium as the anion ତା ମାନେ ଏମିତି କହିପାରିବ ଯେ more the stability of the anion better is the nucleophile more the stability of anion better is the nucleophile okay so sorry better the leaving group not nucleophile so there are few questions I have given in last class ताल देखियो एठी जोठी anion ର stability अधिक अछि जो back bonding हो कि resonance हो so these are the effects those can increase the stability of the anion so accordingly the stability is increased ठीक so tapre eta हम किछ क्वेश्चन डिस्कशन करथिले now we are going to discuss next that is reactivity of haloalkene reactivity of haloalkene student please all of you mute yourself जब हम haloalkene देखिबा so this is the haloalkene that means the bond is present between carbon and halogen between carbon and halogen carbon is less electronegative and halogen is more electronegative since halogen is more electronegative so it will be released in the form of anion so we can say when the bond is to be dissociated between carbon and halogen then it is going to make carbon cation and halide ion okay so this carbocation is formed so which is the reactive site now the reactive site is CX bond the reactive site is CX bond so when the CX bond is dissociated it has to be dissociated heterolytically and it forms carbocation as well as the halide ion so हम कौन कहि परिबा ना more the stability of carbocation कहेंगे ना carbocation is the intermediate carbocation more is the reactivity of haloalkane more the stability of carbocation more is the reactivity of haloalkane shouldn't quickly note down of this up to this quick In haloalkane, the reactive site is CH bond, which undergoes heterolytic cleavage. The reactive site is CX bond, which undergoes heterolytic cleavage to form carbocation and halide ion. To form carbocation and halide ion. More the stability of carbocation, more is the reactivity of haloalkane. More is the reactivity of haloalkane. তাহলে লেখো কিছু কোশ্চেন। arrange the reactivity of Can I write down the question? I hope all of you are writing. These are the three questions. You have to arrange the order of stability, order of reactivity. Okay, आगो क्वेश्चन लिखी दो, तापर 1 2 3 4 तो मार्क करके आंसर लिखो. Take 2 minutes. I hope all of you are doing. Quick. Over. So question number 1, going to write the answer first. This is D, C, B, A in the decreasing order. And question number 2 again, D, C, B, A. And question number 3, first E, then D, then B, then C, then A. Compare with your answer. Then I'm going to discuss it. Okay, see here. First, ଆମେ ଏଠି କ'ଣ ଦେଖିବା? ଏଠି ରେଜୋନାନ୍ସ ତ ନାହିଁ. So ରେଜୋନାନ୍ସ ଯଦି ନାହିଁ, ଆମକୁ ସିମ୍ପଲି ଦେଖିବାର ଅଛି ଇଣ୍ଡକ୍ଟିଭ ଇଫେକ୍ଟ and hyperconjugation. So in first, how many hyperconjugated hydrogens are there? 0. And this is 2. Here 6. Carbocation बनिला परे. Then here 9. So more the number of hyperconjugated hydrogen, more is the stability of the carbocation. Second देखिवा, all the alkyl groups are same. ताले reactivity कहाँ पे depend करिवो? That it depend करिवो on the leaving group. So better the leaving group, it can be easily released out, and it can be easily released out, more is the reactivity. Okay, more is the reactivity. So it better leaving group क्या होगा? Iodide, then bromide, then chloride, then fluoride. Next जैसे देखिवा, hyperconjugate hydrogen, here 2 carbocation बनला परे, here it is 5, this is 4, this is 3, 6 plus 2, 8, and this is 9. Okay, 9. So that means more the number of hyperconjugated hydrogen, more is the stability of the carbocation. So it is clear. So any doubt, student, up to this? If any doubt, write in the chat box. Okay, next. Next is reactivity of haloalkane and haloarine. So if you compare the reactivity between haloalkane and haloarine, which is more reactive and why? Okay, which is more reactive and why? See, if you see this chlorobenzene, we can draw the resonance structure because chlorine has lone pair. So due to the presence of lone pair, it can make resonance, and that effect is known as Plusser effect. So Cl plus minus this. Next, Cl plus, this is minus, minus, Okay. So quickly note down the resonant structure of chlorobenzene. तापर हम तक explain करिए. जल्दी लिखो students. The resonant structure of chlorobenzene. Okay. So हम कौन कही परिबा ना in chlorobenzene carbon halogen has partial double bond character due to resonance. So student quickly note down in haloarine in haloarine carbon halogen has partial double bond character due to resonance. अब तुम जानছো bond order is directly proportional to bond strength. Yes or no? Bond order is directly proportional to bond strength. তাহলে bond order কোটি अधिक होला 9 haloarine as compared to the haloalkane. তাহলে more the bond order, more the bond strength. That means it is more difficult to dissociate. যদি dissociate হওয়া difficult হবো তাহলে কো the reactivity কোন হইଯିବ কমিଯିବ. So it has lesser reactivity as compared to the haloalkane. Write down. Haloarenes are less reactive. Haloarine जरा student पचारछि haloarine means aromatic halide. So that means RX means aliphatic halide and haloarine means aromatic halide. जैसे benzene गोटे aromatic compound तार halogen को हम कौन कहेगा ना haloarine. Okay. So right in haloarine carbon halogen has partial double bond character. As a result of which it is less reactive. It is less reactive than the aliphatic halide. Less reactive than the aliphatic halide. जोटा में RX कहूचे ताके में aliphatic halide बोली कही परिबा. ठीक है स्टूडेंट ता माने कोन कही परिबा ना जेंति in general again same more the wait student more the stability of the intermediate more is the reactivity of the haloalkane. Okay, so now we are going to discuss some more questions. Student, keep quiet. Okay. All of you mute yourself. Okay. Next is I'm just going more the stability of carbocation, more is the reactivity. Now write some questions. Arrange reactivity of first write down the reactivity order. Write on the reactivity order of these haloalkane and halorine. Then quick. Okay, these 4 questions. Take some time. First write down the question. तापरे ताको solve करो. Friend, I hope all of you writing the question. And doing the all of you trying. Okay. So should I discuss? ଯଦି କାହାର complete ହେଲା, write in the chat box if anyone has completed. अच्छा, do you want more time? Okay, take 2 more minutes, quick. So now we are going to discuss the answer. Question number 1, the answer is this is 3, 2, 1, 4. It is 1, 3, 4, 2, And question number 3 is 2, 3, 1, 4. And this is 1, 3, 2, 4. Then quickly compare with your answer. Explain kariba. Compare with your answer, then we'll discuss. Okay. Sorry. Question number 1 देखो. It is vinyl group. जानছো vinyl group starting discuss करते vinyl means double bond सहित यदि किसी group attached अछि along with the double bonded carbon, if any group is attached, then that is known as the vinyl. So vinyl means here resonance is taking place, and in last again aryl halide, so resonance is taking place. ताले resonance हेले कोन हो partial double bond character हो. So कोड अधिक partial double bond character हो 4 रे as compared to 1. So the reactivity of 1 is more than that of 4. The reactivity of 1 is more than that of 4. Okay. So सेटा कहया दरकार नै. Question number 2, first is benzyl carbocation. So benzyl carbocation is stabilized by resonance. Benzyl carbocation is stabilized by resonance. Okay. Then upcoming कहबा vinyl, and this is allyl, this is benzyl, and this is haloalkene. This is aryl or haloalkene. Okay. So haloalkene or vinyl again partial double bond character रहेगा. Stability देखिबा. Benzyl has more stability than allyl in the benzyl. Next, question number 3 रे all are benzyl carbocation. ताले जहाँ भी difference होगा due to the presence of the group or atom present at the para position. So OH ର nature कौन रहेगा? This is plus R. This is 3 hyperconjugate hydrogen or plus I. This is minus R or minus I. Okay, minus R or minus I. तमें कौन कही परियो? ना minus I and minus R groups decreases the stability of carbocation intermediate, whereas plus R increases the stability to greater extent, followed by plus I. Plus R increases the stability to greater extent, followed by plus I. Okay. तामने plus R जो सबटा अधिक stability increase करेला, so से highest है गला, then plus I, then no effect, जोटा कि only benzyl carbocation से no effect है गला, और last कौन है minus R that decreases the stability. Got it? Okay. Now next is here 3 hyperconjugative hydrogen. Here also 3 hyperconjugated hydrogen. तुम जानछो resonance and hyperconjugation both are operative only at the ortho and para position. Now meta position कौन होगा? Plus I effect होगा. Okay, plus I effect होगा. तुम जानछो hyperconjugation has more power than plus I. Hyperconjugation has more power than plus I. The hyperconjugation effect will stabilize the carbocation more than that of the plus I effect. ठीक. अच्छा इठी रहला हम 3 hyperconjugated hydrogen, first ଆଉ third रे 3 hyperconjugative hydrogen अछि. जेदा first और third रे 3 hyperconjugated hydrogen अछि, ताले त stability कोन होबो? अधिक हो plus I अपेक्षा. Now between first and third, which has more stability? Now first has more stability. काहेकि hyperconjugation दिटारे equal अछि. But जदि हमें inductive effect देखिबा, so it decreases with distance. ता माने ortho position रे inductive effect रो power अधिक रहिबो as compared to the para position. Okay. So plus I has more power at the ortho position as compared to the para position. So this is the answer that चाहूचो quickly 1 minute नहीं तमें explanation निजे लिखी दियो. Students make it fast. Quickly write down the explanation. Writing. Okay. Next is we are going to discuss the next, that is the nucleophilic substitution reaction. Just one. So nucleophilic substitution reaction. Okay. So how to represent the nucleophilic substitution reaction? The nucleophilic substitution reaction ଏମିତି ଲେଖିପାରିବା leaving group is substituted by the nucleophile, so it becomes this plus leaving group, right? Nucleophilic substitution reaction. ଏବେ just start କରିବା, then after the short break ଆକୁ ପୁଣି ଆଜି ଆମେ SN1 SN2 ଦୁଇଟା detail discuss କରିବା, right? Nucleophilic substitution reaction, it is a reaction in which the nucleophile, the leaving group, in which the leaving group is substituted by the nucleophile. The leaving group is substituted by the nucleophile. Okay. Now, types of nucleophilic substitution reaction. First, SN1, SN2, SNI, NGP. SN1, SN2, SNI, and NGP. Write down. So first, I'm the keyword SN1. SN1. So it is nucleophilic substitution unimolar reaction. It is nucleophilic substitution unimolecular reaction. Okay. That means unimolecular reaction माने कौन? That means order of reaction is 1. Order of reaction is 1. Okay. So it has first order reaction. ताले जब हम एठी in general represent करिचे, then the rate of reaction is proportional to the substrate only. Which is the substrate here? Haloalkene. Or R equal to K into substrate. are equal to K into substrate. This is the example of SN1 reaction. Okay, this is the example of SN1 reaction. Okay, any doubt up to this? If you have doubt, write in the chat box. No? Okay, good. Now, we are going to write the mechanism. Mechanism of SN1 reaction. So first is in the presence of step 1. In the presence of polar protic solvent, departure of leaving group takes place and hence carbocation intermediate is formed. This is the first step. In the presence of polar protic solvent, departure of leaving group takes place and hence carbocation intermediate is formed. This is the very first step. Okay. Like suppose we are taking this polar protic solvent कौन plus leaving. Second, जोटी भी carbocation intermediate form हुए. Okay. So whenever the carbocation intermediate is formed, it may undergo rearrangement to form more stable carbocation. The carbocation intermediate may undergo rearrangement to form more stable carbocation. May undergo. तामाने सबुबले हबो किछि जरूरी न. नोट डाउन कर दियो. फर्स्ट स्टेप रे फॉर्मेशन ऑफ कार्बोकैटायन, सेकंड स्टेप rearrangement of carbocation. Our second step सबुबले हबो किछि जरूरी न. In specific cases it is going to take place but not always. Second step is clear. Now come to third step. Attack of nucleophile to the stable carbocation center to form the product. तामाने this stable carbocation center, the nucleophile makes the product with the stable carbocation center. Okay. So these are the 3 steps. So make it fast. Note down. written? Okay. Student, after writing this, take the short break of 10 minutes. तापर हमें आपको डिटेल डिस्कशन करिबा. Then factors affecting SN1. तापर हम डिस्कस करें SN2. Factors affecting SN2. So हम तो डिस्कशन करिबा. Okay. Take the short break. ଆଉ ତମକୁ କ୍ଲାସ୍ ମାନେ ଲଗ ଆଉଟ୍ ହବା ଦରକାର ନାହିଁ. ଷ୍ଟେ
ଟ୍ୟୁସନ ଦରକାର ନାହିଁ ସେଠି ତ ହଉଛି ସବୁ। ମୁଣ୍ଡ ଖରାପ। ତ ତୁମର ରେଗୁଲାର କିଏ ଜଏନ୍ କରୁଛ? ଟାଇମ ହଉନି ନା।
क्वेश्चन पूछ रहा भी है।
Okay, student, welcome back. Now, what are the factors those can affect SN1 reaction? Okay, those can affect SN1 reaction. First, nature of haloalkane. First, nature of haloalkane. Okay, যদি আমি দেখিব the reaction goes through the formation of carbocation intermediate. That means more the stability of carbocation, means লিখিପାରିବ more the stability of carbocation, more is the more is the more is the rate of SN1. More is the rate of SN1. Suppose we are taking methyl, ethyl, this and tertiary means primary, secondary and tertiary. Okay, so primary it is methyl 1 degree, 2 degree and 3 degree. So what is the order of reactivity? 3 degree greater than 2 degree greater than 1 degree greater than methyl. Kahingi? Na tertiary carbocation is more stable, then secondary, then primary. Okay, so this is the first. Then second, nature of haloalkane gala, nature of living group. Nature of living group. I'm going to say better the living group, it can easily be released. ଯେତେ ଇଜିଲି ସେ କାର୍ବୋକେଟନ୍ ସେଣ୍ଟର ରିଲିଜ ହବ ସେତେ ଅଧିକ ରିଆକ୍ଟିଭିଟି ହବ କାହାର towards the nucleophilic substitution reaction. So better the living group, more is reactivity towards nucleophilic substitution reaction. Better the living group, more is the reactivity towards nucleophilic substitution reaction, SN reaction. Okay, so this is the second factor. Third, nature of nucleophile. आपको सब नोट करो जदि गोटे न्यूक्लियोफाइल बेटर न्यूक्लियोफाइल थिबो और स्ट्रांग न्यूक्लियोफाइल थिबो जोटा हम न्यूक्लियोफिलिसिटी कहउचे सो कोई भी SN1 रिएक्शन हो कि SN2 रिएक्शन हो से फास्टर ही हबो सो मोर द न्यूक्लियोफिलिसिटी more the nucleophilicity, more is the nucleophilic substitution reactivity. More the nucleophilicity, more is the nucleophilic substitution reactivity. Student एक पॉइंट टेक क्विकली नोट कर दिया, टेक 2 minutes के नोट कर दिया. Student mute yourself. Okay, up to this clear? All of you written? Then fourth, nature of solvent. So which solvent facilitates the SN1 reaction? Now this reaction takes place in polar protic solvent. Why? Because departure of leaving group becomes easier in polar protic solvent. Departure of leaving group, LG means leaving group, becomes easier in polar protic solvent. Okay, quickly note down. Up to this clear? Okay, next ଆଉ କ'ଣ factors ଆସିପାରିବ କୁହ? ଆମେ ଦେଖିଲେ living group, then nucleophile, then ଦେଖିଲେ nature of the haloalkene or substrate, ତାପରେ ଲେଖିପାରିବା concentration of nucleophile. Concentration of nucleophile. Okay, so we have seen at the beginning here the rate of the reaction is dependent on only the haloalkane or substrate, is independent of the nucleophile. তাহলে nucleophile concentration increase kale bhi, so there will be no change. Okay, kahinki nucleophile is not present in the slow step or rate determining step. So constant nucleophile, no change. So need explain कर लिख दियो. There is no change on the rate of the reaction. There is no change on the rate of reaction by changing the concentration of the nucleophile. As the nucleophile is not present in the slow step. Is not present in the slow step. Okay, up to this clear? अच्छा स्टूडेंट देखो जैसे हमें mechanism जिबा उथरे. So here in the first step, in the presence of polar protic solvent, departure of leaving group takes place and hence carbocation intermediate is formed. Okay, so एठी कोन ना generally bond dissociation जोटा slow थाए और bond formation fast थाए. तो एटा this is slow step, एटा लिखि दियो, it is slow step, add कर दियो, and hence rate determining step RDS. एटी कोन अछि slow step रे except the apart from the solvent आ कोन अछि only haloalkane अछि. ताले rate of reaction कहाँ पे depend करिवो? haloalkane पे depend करिवो. ताले it is the slow step and hence RDS, that is rate determining step. Okay, so fifth point is clear. Next time देखिबा stereochemistry. खाली एक heading लिखि दियो stereochemistry. So what will be the stereochemistry in nucleophilic substitution reaction? खाली हमें SN1 कथा कहबानी, एट देखियो SN2 रे भी stereochemistry कोन अब SNI रे and NGP. What will happen to the stereochemistry? Stereochemistry can be classified into three. One is retention, second inversion, third racemization. Okay. Retention, inversion, then third is racemization. So depending upon the stereo or based on the stereochemistry, it can be retention, inversion, or racemization. So what is retention? Now retention means where the student note down, dictate करके note कर दियो. Retention means nucleophile will be substituted. Nucleophile will be substituted at the position where the leaving group was present. Where the leaving group was present. Clear? That is retention. Man जोटी living group थो सेठी nucleophile substitute होगा. So हम तक retention को living group, this is nucleophile plus living group. Then inversion opposite to the living group. That means nucleophile, living group, and racemization. Racemization कौन? ना retention plus inversion. Racemization means it is both the retention and inversion. Living group plus nucleophile. This is example of inversion, and this is example of retention. So in racemization, both inversion and retention are taking place. Both inversion and retention are taking place. Okay, so quickly note down. In the case of SN1, what is taking place? Okay, in the case of SN1, what is taking place? Will it be retention or inversion or racemization? हम देखिले एटी mechanism रे after the formation of carbocation intermediate, nucleophile is attacking. Yes or no? So carbocation has, this is the carbocation center which has planar shape. This is the nucleophile. Okay, nucleophile is present everywhere. So in the medium or in the solvent. So once the carbocation is formed, then it has two options. The nucleophile can attack from the position where the leaving group is present, retention बोली कहवा, and it can attack from the opposite side, so that is known as inversion. So in SN1, it is the racemization of configuration. Okay, it is the racemization of configuration. Both side means racemization, right? In SN1, it is the racemization of configuration. That means both retention and inversion are taking place. Both retention and inversion are taking place simultaneously. Okay. Now the question is whether both the retention and inversion are taking place equally or different. বুঝিপারছো? Equally হবো না different হবো? That is the question. তাহলে লেখো. Any idea? Right. In this case, more inversion of configuration than the retention. କାହିଁକି inversion ଅଧିକ ହବ? ବେଳେ ବେଳେ କଣ ଲେଖା ହୁଏ ଅପସନ ରେ ଆସିଥିବ କମ୍ପିଟିଟିଭ ଏକ୍ସାମ ରେ ଆସେ it is racemization plus inversion. It is racemization plus inversion. Okay, clear? So right, ଗୋଟେ explanation ଲେଖିଦିଅ. ଯେତେବେଳେ explanation ଦେଖିବ ଯେତେବେଳେ ତମର living group release ହେଉଛି so after releasing the living group it will be closer to the nucleophilic or electrophilic center. It will be closer to the electrophilic center. Okay, right? After releasing the living group, it will be closer to the carbocation center due to Coulombic force of attraction. କାହିଁକି କାଟାୟନ ଆନାୟନ ଭିତରେ Coulombic force of attraction ତ ରହିବ ବୁଝା ପଡିଲା? Due to the Coulombic force of attraction. As a result of this, the front side is partially blocked. Whereas the opposite side, don't all of you mute yourself, whereas the opposite side can easily be attacked by the nucleophile. So more inversion and less retention. So with this, SN1 reaction and factors are over. Next देखिए SN2 reaction. So what is SN2? SN2 is nucleophilic substitution bimolecular reaction. Nucleophilic substitution bimolecular reaction. That means order of reaction is 2. Order of reaction is 2. Okay, order of reaction is 2. So we can represent the reaction or rate that is proportional to the concentration of substrate on nucleophile, or R equal to K substrate into nucleophile. So now you can see the order of reaction is 2. Order of reaction is 2. Okay. তাহলে দেখি mechanism. So এটি কোন হবো না, this is the haloalkene. ଆମେ ତାକୁ X ବୋଲି ନେଇ ପାରିବା. Suppose ଆମେ chlorine ନେଇ ପାରିବ, chlorine and nucleophile. So nucleophile attacks the electrophilic carbon from opposite side of the leaving group. So it starts making bond with carbon, and simultaneously the bond between carbon and leaving group becomes weaker. So under this condition, this is known as transition state. Both the leaving group, under this condition, both the leaving group and nucleophile are simultaneously attached with the carbon center. Then what will happen? A nucleophile makes permanent bond and the leaving group is released from the carbon center. Nucleophile is released from the carbon center. So quickly note down the reaction. तापर मैं तुमको okay. तापर मैं तुमको तार theory dictate कर देवी. Right. Note down quickly. Okay. As a student, you might have seen here that the formation of bond between the nucleophile and carbon center and dissociation of bond between the carbon center and leaving group, both are taking place simultaneously. So it is, this mechanism is known as concerted mechanism. This is known as concerted mechanism, right? Quick. SN2 follows concerted mechanism. That means both the bond formation and dissociation takes place simultaneously. Clear? Right? Nucleophile attacks the carbon center. Nucleophile attacks the carbon center from the opposite side of the leaving group. It starts making bond with the carbon and simultaneously the bond between the leaving group and carbon center becomes weaker. Leaving group carbon center becomes weaker. Finally, the leaving group is released out. And nucleophile makes permanent bond. Okay, permanent bond. Now next, write down factors affecting SN2 reaction. First is nature of haloalkane. So haloalkane nature कौन हबो आ एठी हम देखिले मेजर फैक्टर कौन हबो ना मेजर फैक्टर इज द स्टेरिक क्राउडिंग yes or no मेजर फैक्टर इज स्टेरिक क्राउडिंग जेते अधिक स्टेरिक क्राउडिंग रहिबो सेते अधिक डिफिकल्ट हबो फॉर द न्यूक्लियोफाइल टू अटैक टू द कार्बन सेंटर सेते डिफिकल्ट हबो फॉर द न्यूक्लियोफाइल टू अटैक टू द कार्बन सेंटर बुझा पड़लानी तार लेखो steric crowding is a major factor. Steric crowding is a major factor for SN2 reaction. SN2 reaction. That means lesser the steric hindrance, more is the more is the rate of SN2 reaction. SN2 reaction. ହେଲେ ଏଠି କ'ଣ ହବ ନା ଅର୍ଡର ହେଇଯିବ SN1 ର ଜଷ୍ଟ ଅପୋଜିଟ୍, ମିଥାଇଲ ପ୍ରାଇମେରୀ ସେକେଣ୍ଡାରୀ ଦେନ୍ ଟର୍ସିଆରୀ। write down ହେଲା। Second, what is the second factor? What is the second factor? Nature of living group. Same. Nature of living group. Okay. So better the living group, write down. Better the living. Better the living group, more is the rate of nucleophilic substitution reaction. Next, nature of nucleophile. Nature of nucleophile. So what will be the effect on nature of the nucleophile? Now that तम जानछो, again more nucleophilicity or better the nucleophile, more is the chance of SN2 reaction or SN1 reaction, any nucleophilic substitution reaction. Okay. So what is the next factor? Next factor is, देखो ये factor compare कर लिखले तुमको easy होगा. So first है nature of the haloalkene, then nature of the living group, nature of nucleophile, तापर nature of the solvent. So nature of solvent कौन होगा इठी? Polar aprotic solvent. कहेंगे ना polar aprotic solvent रे nucleophile will be highly solvated. The nucleophile highly solvated, ताले सेठी कोन हम कहबा जदि nucleophile highly solvated हबो ता rate of attack decrease ହେଇଯିବ. Okay, rate of attack decrease ହେଇଯିବ. ठीक. Next is एरा तोर nature of the solvent, right? SN2 reaction takes place in the presence of polar aprotic solvent. In the presence of polar aprotic solvent. ठीक. Okay. ଆଉ कोन ରହିଲା next? What is तमरो stereochemistry, concentration of nucleophile. Concentration nucleophile. And then in SN2, it is rate of reaction is proportional to or equal to K into substrate into nucleophile. ता माने आमे जे nucleophile concentration increase करिवा, so rate of SN2 reaction increase हबो, right? With the increase in concentration of the nucleophile the increase in concentration of the nucleophile, the rate of reaction increases. Okay, rate of reaction increases. Next, stereochemistry. So what will be the stereochemistry here? Then we discuss करथिले ना retention, inversion, racemation. So here complete inversion of configuration, right? SN2 goes through complete inversion of configuration as the attack of nucleophile takes place only from the opposite side, only from the opposite side of the leaving group. So it is complete inversion of configuration. Okay, complete inversion of configuration. Got it? Okay. Now compare, you have to compare between SN and SN2 reaction. Take 2 minutes. A factors नेके तो compare करो between SN1 and SN2 reaction. Clear? Make it fast. Compare between SN1 and SN2. Nucleophile ಎಲ್ಲ concentration nucleophile, nature of haloalkene, सब factor नहीं तो compare करो. over students. तुमको फैक्टर कही आम फर्स्ट है नेचर ऑफ हालोअल्केन SN1 रे कौन हम टर्शियरी ग्रेटर देन सेकेंडरी ग्रेटर देन प्राइमरी SN2 रे रिवर्स ओके SN2 रे रिवर्स हो देन आउ कौन फैक्टर है कह concentration of nucleophile जब कंपेयर न कर डिफरेंस करियो एटा आसीबो concentration of the nucleophile ओके थर्ड जोटा कि SN1 इंडिपेंडेंट रहे SN2 इंक्रीज हो देन नेक्स्ट टाइम कौन नबा नेचर ऑफ सॉल्वेंट SN1 polar protic SN2 polar aprotic then stereochemistry SN1 racemization SN2 is inversion ठीक है so these are the factors अच्छा now write some conversion 2-3 questions these 3 questions take 2-3 minutes and solve these 3 questions Student tried? How many have tried? Okay. Going to discuss. First, terminal position OH means you have to follow hydroboration oxidation reaction. That means the double bond has to be formed at terminal position. तो जानछ हमें alkene रू only haloalkene बनै परिबा. Again, जदि different carbon थिबो, so we can apply only bromination. So it is 2 bromo, right? So terminal position double bond ପାଇଁ हमको bulky base use करिया पड़िबो tertiary butoxide. This but6 H2O2. First one is clear. Okay. Next, again, propane, we can apply only bromination to form 2-bromopropane, alcoholic OH, this, then hydrogen bromide. Thank you. A terminal product only we can take this. हमको iodine दरकार अछि, sodium iodide, acetone. So Finkelstein reaction. Last, same. Then alcoholic OH. Then terminal position, so hydrogen bromide in the presence of peroxide. हम कौन दरकार अछि? Fluorine. Note down quickly. With this, we have discussed SN1, SN2. So next class, we will discuss SNI and NGP. Then we'll discuss some questions. Note down. And if you have finished, then you may leave the class.